Everyone got the thing done? I hope. Okay. So, again, sorry, everything was just chaotic this morning because the grades were updated or finalized for semester 1 this morning. And my freshmen and my inclusion algebra, oh boy, did they decide work was optional last semester. And it was kind of a bloodbath. So we had to get some things straightened out. So, again, every day you come in, quiz awaits you. You do thing. Open notes, open book. Open every resource, just like you'll have on your actual tests. I want you fully supported. Human beings do not memorize crap. We look it up. You ask our IT guys. You know, they don't code a site from scratch. You take modules, you build with existing bits of information. You look things up. I want you to look things up. I'm the teacher. I look stuff up. Okay? If you have all of that, can you do what we did yesterday? That's all this is. So now let's check it out. Symbol-wise, what is the that? Intersection, and it is the and of the set world. What is the that? Not. Remember, you can use not, or you can use prime to mean not B or complement of B. They're both referring to the same object, the same space, everything that was not in B. So if I want everything that is in A and has to be in B, or not B, that means I have to take all of A, and it also has to meet the condition of it was not in B. 2 and 8. That's it. Come on, you get out of there. Next one. It's going to be a union, not B. So that one is everything that was not B no, something like that. Everything that ain't in B, or it is in A. Because it says or, who's now allowed to the party? No. A or stuff that's not in B. Okay. Try again, maybe the whole works. We do, get down here. So, A, all of this stuff. Or stuff that's not in B. Okay? So it's all that stuff. A was 1, 2, 5, 8. And stuff that was not in B is 6 and 7. And then simplifying complex numbers. Multiply by the conjugate. -2 plus I. Remember, don't change the sign on the 2. It's always you change the sign in between. That's what makes it a conjugate. And -2 plus I. So, disturb up top, -10 plus 5I minus 6I plus 3I squared over -2 is 4 minus 2I plus 2I minus I squared. Within there, I squared is -1. I squared is -1. Cancels out. So 4 plus 1 is 5. I'm already going to separate my real friends and my imaginary friends. If you didn't, that's okay. And negative 10 minus 3 is a negative 13. 5 i's minus 6 i's is a negative I. So I'll say negative 1/5 I. If you had written it like that versus you said negative 13 minus I all over 5, I'll still take it. Again, at some point, you're going to have to input stuff on a computer screen for math. And they're going to count it wrong if you do that. I don't care. They're going to care. And then you're going to be bitter about it. I'm still bitter about the thing I missed on my ACT 20 years ago. It happens. So, those are the things. What we do is every time it's going to be something out of 5. So, off to the side, you got something out of 5. And we just assign our 5 points accordingly. Sometimes it's, I want you to hit these specific skills. I want you to get these certain things right. Other times it's going to be a Likert scale, the rating scale. 5, I did great. 4, I missed the one little thing, and I'm pounding my head into the table because why did I miss the little thing? Even if it's a domino effect and screws up everything else in the problem. 3, yeah, I screwed up. That was a bonehead move. It was bad, but I got the concept. I just screwed it up. 2, wow. Yeah, cone of shame, kind of. Wow. But I at least tried to do the thing that we were doing. Like there was something there about the concept we were working on. 1, waffles. I don't know. You have something related to math up there. Good job. You tried it. And 0, you didn't even do that. Okay? So sometimes that's what we have to do. In this case, I'm going to say, did you get it? Did you get it? Did you get it all the way? Because I know that one was a little bit tougher, that whole idea of or. Okay, so maybe you had like 4 or 5 of these, but you're missing 1 or 2 of them. Like, God, I completely forgot 6 was hanging out there. Okay, something like that. Down here, it's going to be, did you... I'm just going to say 2 points altogether for, like, did you multiply by the correct thing? Did you multiply correctly? Or maybe you just missed a negative when you were multiplying. Doing all of that work to get to the final result. So that, again, if you haven't been here before, you're going to hear me talk about the domino effect an awful lot. I do not want to penalize a kid and say 2 points off because way back here you said positive 2 plus I. Did you still multiply everything correctly? Did you still write it correctly as a complex number? You did everything that you were supposed to based on incorrect information. 1 off, not 2. Okay? So there's your 5 points. You put something out of 5, circle it, box it, different color, whatever you're going to do. And it should be somewhere labeled, somewhere accessible. I really like when kids have, like, here's my assignment, and then just on the back page, there's my daily quiz. Lets me flip through those real fast on quiz day. I've had other kids where they have their homework in one section of a binder and then another page that's just all their daily quizzes from that week. Okay, whatever your jam is, as long as it's labeled, organized, and I can find it when you turn it in. And you hold on to that. You hold on to the notes. You hold on to the assignments. You hold on to all of that. I want to spend my time working with kids, not pushing around papers. You know the teacher that says, okay, now do your work because I have grading to do, and they do that 3 times a week. Like, I don't want to do that. I didn't become a teacher to push papers around. I want to work with kids. So instead, you just turn your stuff in every quiz, and that's it. We take a quiz, you throw your notebook or binder on the counter, I go through it. Sometimes life happens and I don't get to it. I say, all right, that sucked. Take your stuff back. I'll get it again next time. And it's no big deal. Okay? I'm gone on quiz day. I didn't turn in my book. All right, turn it in next time. I was out for a week and I don't have my assignments done. Cool. Hand it in next time. Like, low stress. Okay? So, there's that. You go away. That looks really funny in blue. Looks like Blue Man Group. Here. That is really creepy. But the fun part is, none of the inverted colors, they show up on the live stream. So it looks normal on the live stream. It's just my board that's inverted. Oh wait, no, this is McGraw. You know, go on you. There we go. Well, for those of you who used the online book and were stuck using Pearson before, are we liking the ability to just nicely come down here and, you know, type in the page and now it works? Boy, that's slick. It's almost like that's a basic accessibility feature that should be in every book. So, talk to me about section 1. Do we got any questions there? I don't want to spend 15 minutes every day going through, I have this question and this question and this question and this question. If you had that many questions, why didn't you send something on Remind? Okay? Now, I don't want to discourage questions. I just want you to use the solution manual and ask questions on Remind beforehand. And if you still have questions, or maybe you just forgot to ask, now is the time. So, anything from section 1 on the sets? Maybe they worded something goofy, you weren't really clear if it was, am I supposed to do this or am I supposed to do that? Nothing? Okay. What about 2? Come on, Frank. Oh, you Anything on 2? Did I assign 32 or 33? I hope I did. Come on, you. I wonder if they just didn't get to that last semester. And so I included it in the next section of homework. The only thing that I want you to be careful about with these, I know it's a problem every year. Why might that be confusing? The square root. Where does the square root go to? Right? Unless you got really good handwriting, which of those is square root of 2 as a coefficient of I? Which of those is the square root of 2I as a radicand? Right? Unless you got really neat handwriting, it's hard to tell. Here, yeah, I can see that stops right before the I, but boy, do they smash that right up against it. And it's hard to tell that there's a separation there. So the way that you'll usually see this written, this is the technically correct way to write it, but the way we normally write it, and like back in Algebra 2, as we're working, is we say this is 2 minus I root of 2, 3 plus I root of 6. Like maybe you remember in Algebra 2, as you'd solve with quadratic formula, you'd call it like 2I root of 3. Technically, it's supposed to be 2 root of 3 I. But we would write it the other way because it was easier to tell that I wasn't a part of my radicand. So that's the only thing. I would just be careful about that as you're working through these. And if you ever have a question of whether the I is under the radical or not, just ask. Take a picture. Yo, is that inside or outside? Sometimes I'll answer, what do you get when you cross an elephant and a rhino? Hell if I know. Try it, see what happens. Okay? So, nothing? We felt fairly confident? Again, most of you coming right out of Algebra 2, this Chapter 0 should go fairly fast, which means I have hope that we can knock out all of review of quadratics. This is the entirety of Chapter 4 from Algebra 2 today. You've been doing quadratics since Algebra 1. If you can't quadratic, after today, if you're just like, I went cross-eyed, I felt like Gizmo, the little Mogwai from the Gremlins movie with his eyes spinning after too much candy. If you feel like that after today, yeah, we might be in for a struggle because it's expected. You've been doing this for 3 years, 4 years. You should know how to quadratic. So, let's get our review on. Starting with some basic vocabulary and features. What are those? Parabolas. The function itself is called a quadratic. The graph of the quadratic is a parabola. Features. What's that? Y-intercept. Yint. The Yiddish cousin of yeet. What is this down here? Both. Okay. It is a vertex, and it can be either a minimum or a maximum. And you probably remember that you can have relative minimums and maximums on larger polynomials. In these ones, they would be absolute minimum and absolute maximum because they are the highest or lowest that my y values ever go. And this one, he doesn't get a special name. No special name. It's just, I can have a mirrored point reflected across a what? Okay. If I take all of that and smash it together, Axis of Symmetry is a line of reflection, and it has the equation x equals number, like the y-axis. So this is my Axis of Symmetry. And we might remember formulas for these, especially coming fresh out of Algebra 2, having taken a final just last week. But we'll get to that. Let's see what you remember. Everyone here needs a graphing calculatron. You forgot to stomp your foot too, Moana. Everyone needs graphing calculator. I gotta ask, who in the room is rocking alternate tech? Does not have a TI, but you got real good with that last semester. Okay. I personally believe that Casios are the superior brand. They are menu based. They do so many cool things. They're half the price. That thing's like 50, 60 bucks compared to the TI-84s are 115 to 130. Is there anyone in here who's got that mathematical drip? You got a TI Inspire? Those things will practically do your taxes. No? Okay, good. Because I have no idea how to run them. I don't have money. So if you have that, the very first thing we do is say, can you graph something using a table? We learned in Algebra 2 that the ancient magic is actually very good magic. Meaning, if I have no freaking clue how to graph something, I can always graph by table. Now, the way that you first learned it was, remember this? Okay. Now, for those who are already starting to press buttons, like, all right, I got this. I'm going to fill in the table. No, we don't fill in the table. We make the calculator fill it in for us. We're big kids now. Okay, where's the table? Okay. Oh, I want everyone to write this down. If you don't already know, because I'm tired of my calculators not working because they have lead stuck under the reset button. Second plus 7, enter 2. Second plus 7, enter 2. Second, right above plus, is memory. Option 7 resets the entire calculator's memory. I want you to look at the other stuff that's in there, though. We're going to be using our lists in our stat diagnostics, and a good amount in the first couple of chapters. 7 is reset. Enter says, yes, I want to get rid of everything I put in here. 2, reset. Second plus 7, enter 2, reset. Okay, because you got a bunch of garbage in there because we just finished finals. There were kids using these. Some of my calculators don't work because I have to unscrew the backs to clean out the crap next to the reset button. How many of you, every time you got to reset the calculator, you just flip it over and stab it in the back like a vengeful little teenager? You said what about me? Okay. It's a calculator, not a voodoo doll. When you do that, the lead, the graphite from your pencil will get stuck. Like just little bits of grit get stuck under that reset button and it kind of holds it down. And then I have to open it up and clean them out to make them work at all again, because otherwise it's like someone's constantly pushing the reset. It just won't turn on. So please reset it correctly. Now that we got that out of the way. I have a equation. Where do I put it? Y equals. You type in 2x squared minus 8x plus 4. 2x squared minus 8. Not apps. 2x squared minus 8x plus 4. Do what I tell you. There you go. Cool. I got that. And it says graph the thing. And you say, okay, graph. And then you get the kid who sees that on their screen. And they come over here. And they go, eh. And they move on with their life. Wrong. You don't wing it. This says graph by table. Where's the table?
Second table.
Right above graph. Instead of that, I'm going to go second table. And I can scroll around in there at different values, but it gives me what the points will be. You do not have to write them down. Anytime it says something from a table in our class, we don't write it. You're a big kid, look it up on your calculator, do things with the table. Okay? Use the tools at your disposal. So I see a 0, 4, a 1, negative 2, a 2, negative 4, a 3, negative 2, a 4, 4, And off into the wild blue yonder it goes. Connect the dots. My shadow's in the way here. It's really hard to make tall, skinny ones on big board. My hand always wobbles. When you make these, please try to keep it curvy. We want Beyonce, not Amanda Seyfried. Okay, eat something, girl. Okay, no stick figure runway models over here. Don't be putting a V on there. That's an absolute value. Okay, shouldn't be pointy at the bottom. Okay, should have those curves. Right. How do I know that this is my vertex, though?
Because nothing goes below.
Okay, do you know that?
Yeah, because like both lines start constantly up.
Okay, what if the vertex was at 2.1? What if it was just a hair lower than that? I can still know that it is. What about it? What about the points that we just put on there? Tells me that has to be the vertex. Okay, I can plug 0 in to find x-intercepts, or plug 0 in for y to find x-intercepts. I can plug 0 in for x to find a y-intercept. Doesn't get me a vertex yet. Remember, look right below this, axis of symmetry. You notice how we went over at 0, 4 and 4, 4? They were both at the same height. We had at 1, -2 and 3, -2 at the same height. That means right in between them has to be my axis of symmetry. And the axis of symmetry always goes through the vertex. So since they were equidistant apart, I know that line of x equals 2 is my axis of symmetry. In fact, that's what I should write on here. It's not enough to just have this. Let's also put my axis of symmetry as x equals 2. Make sure when you put an axis of symmetry, you don't just say 2. An axis of symmetry is a line. Lines have equations. 2 is not an equation. X equals 2 is an equation. My vertex was down here at 2, -4, and it was a minimum. What else could I label on here?
Y-intercept.
Y-intercept. Yint is at 0, 4. I want you to look back at the original function. Do you see how you could have gotten that y-intercept a different way? It had that +4 at the end. If I put a 0 in for both of my x's, I get y equals 4 as my y-intercept. So, a bunch of different ways. So this is your fallback option, especially for those of you who are maybe you're a little shaky on these. Maybe you're just trying to save time on ACT. Who's set up for that February ACT? Anyone? I know we got more sophomores second semester, so probably not, but juniors, seniors, definitely. Okay. Sometimes you just need to dump it in a calculator to get your information. Now, graphing by table is one method. The other is, can you graph the way that you learned back in Algebra 1? You reviewed again in Algebra 2. Can you algebraically find the vertex and use your perfect square steps? Okay, I'm going to... Okay, I'm actually going to swap. Normally I have kids, I do this one, and then I try to tell kids to do this one, and it doesn't work out because they forget how -3 works. I'm going to do this one up here, and then we'll have you try that one. So, what is that? F of x is -3x² plus... There we go. So the ancient magic is the axis of symmetry is always x equals negative b over 2a. And that's if I'm given ax squared plus bx plus c standard form of a quadratic. Okay, you plug a, b, and c into formulas. It's also, where was it? It was up here somewhere. I thought I had my, there we go, right above beta's head. Okay, axis symmetry, x is negative b over 2a. All of these up here, that's our class. Okay, we review a lot of function stuff, chapter 1 and 2, logs, and then chapter 4 is from there, womp, through most of there. And then the little bit in the middle about conics is chapter 7. Like this is our stuff. Okay. So axis symmetry is x equals negative b over 2a. So x is a negative something over 2 something. Hopefully you've picked that up along the way in your mathematical journey. If you are evaluating, always use parentheses, because otherwise you will screw up negatives and exponents left and right. So my b is 12. My a is negative 3. Negative 12 over negative 6 is positive 2. Awesome. I now know that at x equals 2, I have an axis of symmetry. What does the axis of symmetry always go through? Vertex. A vertex is a coordinate. A coordinate is x and a y. So I'm going to plug 2 in for x to find out y. Right? The oldest mathematical pun ever since you learned linear equations. If you have an x, you better find out y. So I'm going to find the function of 2. Function of 2 is negative 3 by 2 squared plus 12 by 2 plus 11. In goes 2. 2 squared is 4. 4 by negative 3 is negative 12. 12 by 2 is 24 plus 11. 23. Okay. So encounter problem 23. I only have 10 boxes headed north. What do? Change the scale. Now, a normal quadratic moves in perfect square steps because it's x squared. A normal quadratic, don't write this part, says from my vertex over 1 up 1, over 2 up 4, over 3 up 9, because those are perfect square numbers. That's how a quadratic will shape itself. This one, y'all remember your A, B, H, and K from transformations? A negative 3a value means this has a vertical stretch by factor of 3. This thing is going to be a skinny mini. It's going to get stretched 3 times taller. So I have a choice. Do I want to make this go by 2s and then just go a little bit off-road? Or do I want to go by 3s so that my scale matches my stretch? Right? That was that little life hack that we learned. If my scale matches my stretch or compression, then I can just go by my normal perfect square steps. So that's what I'm going to do. I see that I have to go up to 23. I see that I'm going to have a stretch by a factor of 3. So that's exactly what I'm going to do. I'm going to make this go by 3. Remember, you don't have to change your x and y axis the same. I can only change my y if I want to. So I'm going to come up here and put my vertex at 223. Over 2, up 3, 6, 9, 12, 15, 18, 21, 24, back it up. 2/3 of the way through the box. Vertex at 223. Happy parabolas and sad parabolas. Is this thing going to open up or down? And I know because? Negative. Okay. Also, right there above beta's head, we have this sad parabola, right? Okay. There it is. Happy parabola, sad parabola. Positive, negative. So, this thing's going to head downward, and it's going to do so at a vertical stretch of 3, but I have my scale by 3. So from there, over 1, down 1 box, because that's down 3. Over 1, down a box. That was down 3. Over 2, down 4 is normal. I'm going to go 3 times as far. So over 2... I'm going to go over 2 and down 12, but because I'm 3 times bigger, that's 1, 2, 3, 4 boxes. You see how it's always in that same position on the line? I'm able to just have a box equals 3 to match my stretch. Over 3 down 3 squared is 9. So 9 boxes, because that's 3 times further. I'm actually moving 27. So down 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes is actually going down 27. Over 4, down 16 boxes. Over 5, down 25 boxes, and so on, because each of those boxes is worth 3, which matches my stretch. Over 1, 2, 3, 4. Did I just skip a box? I skipped a box. Yoink, yoink. Yeah. Over 4, down 16 boxes, so down another 7. 1, 2, 3, 4, 5, 6, 7. Okay. So this is what, in terms of its shape, this is what a normal quadratic would look like if it didn't have a stretch or compression. The cheater hack is to make sure that your scale matches your stretch or compression so you can just make the same graph every time. I have a bunch of stuff on the right. Axis of Symmetry tells me I can just mirror those over to the left. I can put you over here. I can put you over here. It was 3 to the right, it's 3 to the left. It was 4 to the right, it's 4 to the left. Connect the dots and try not to suck. It wasn't the greatest, but I'm not doing it again. Okay. Now, I know that some of us have had a 9-month gap since the last time we were in Algebra 2. I know some of us have had a year-long gap since we were in Algebra 2. So I'm going to run that again because I just remembered that I have extra practice on the next page. I'll talk about all the stuff with it afterwards. Just let's get the graphs. Okay, this one. My axis symmetry, x is negative b over 2a. What's b? 2. A. So I'll try the function of negative 2 is negative 2 squared plus 2 by negative 2 minus 3. We jam in there a negative 2. What?
Negative 2 divided by 2.
Eat them up now. That's usually what happens. Kids get plenty at the beginning of the year, and as soon as we start getting into new material, the well runs dry. There we go. So, 1 minus 2 minus 3. Cool. Finn, black. Behind you. I don't want to invade your personal space. I don't care much for social boundaries, but physical boundaries, that weirds me out. So, I have a vertex at negative 1, negative 4, so back 1, down 4. Will that be a maximum or a minimum? Minimum, because it's a happy parabola. So I'll say my vertex is down here, negative 1, negative 4. I'll put my axis of symmetry that I found right there. X symmetry, x equals negative 1, 1, not 11. And then I apply my vertical stretch or compression to the perfect square steps. Those perfect square steps is if I have my vertex here, I go over n, I will go up or down a times n squared. Like that's how I make these steps. So a is currently 1. So from my vertex, I go over 1 up 1 squared. From my vertex, I go over 2 up 2 squared. 4. From my vertex, I go over 3 up 3 squared, or 9. From my vertex, I go over 4 up 4 squared, or 16, which is off-road. Okay, perfect square steps. Now, you can always graph by table. But this whole perfect square steps thing for parabolas, y'all, you should have been doing it for 3-4 years now. Okay. I have stuff on the right-hand side, so to the left, 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 to the left. Connect the dots, try to keep it curvy and not suck. But actually hit the points. Okay? So, graphing quadratics is a thing that I've been doing for a long time, but I tell you what, as soon as you give kids that graphing calculator and say you can graph by table if you need to, they kind of forget all of this. Okay? I'm just reviewing it because if you're in this room, it's expected that you know it. If we got to knock a little rust off the gears, then that's what we got to do. Now, you had meh and meh. You had graphs, okay? The questions with them. I want to go back to those. Determine whether the function has a maximum or a minimum. Y'all are pretty good about that. Depends whether it's positive or negative, right? This one had a maximum. This one had a minimum. Find the maximum or minimum value of the function. If you need to write a note next to that, they're asking for the y value of the maximum or the minimum. So what I would say, like this last one was, what was it? -1, -1, -4. So I'd say it has a minimum of -4 at x equals -1. So its value, its minimum value is -4. It occurs when x is -1. When I press this input button, the output of my minimum is -4. And then domain and range. I know that I've been making a stronger effort to really emphasize that in Algebra 2, because too many kids are coming up to PreCalc just shady when it comes to domain and range. What's domain and range? X is allowed into the party, Y is allowed out of the party. Okay? So in this one, okay, it all comes back to my, okay, if you haven't seen it before, here they are. And Mathocles comes down from the mountain with his tablet, chiseled in blood, and it says, number 1, thou shalt not divide by 0. Okay? If I could like paint my hand red and go grug on it, and they died. Okay? You cannot divide by 0. I live in Disney hell, and Croods is one of the few non-Disney movies that we watch pretty regularly. I identify with Grug. Big dumb oaf who does everything wrong, but all I have is my strength. And that's all we need. Yeet the baby. Okay. Number 2. Thou shalt not take even root of a negative number. And they died. What happens when I take an even root of a negative? Imaginary numbers, right? It is literally not possible. So I have evens and negatives. Create imaginary. Number 3, you learned in Algebra 2. Thou shalt not take log of any base of a non-positive number. And they died. Okay? Remember, you can't take log of 0. You can't take log of a negative. Doesn't matter what the base is. You just can't do it because there's a vertical asymptote at 0. Unless you translate it, but then you've messed with the input. Number 4. Parts A and B. Stay tuned. We don't know those yet. Okay, those are in Chapter 4 of PreCalc. They are inverse trig functions. Okay, so right now, those are our commandments of domain. I want you to look at your function. Do you have a 0 or a variable on a denominator? There was never a variable on a denominator, so that means I would never have the possibility of dividing by 0. So I don't have to worry about that one. Did I have an even radical anywhere in my function? Did I have a logarithm anywhere in my function? So if my rules are don't punch holes in my walls, don't eat my goldfish, don't do weird things with my dog. If those are the 3 rules and no one's going to break those rules, who's allowed to the party? Everybody. Okay, Caden's learned his mistakes. Caden ate my goldfish last semester, so no, it was a young gentleman named Ryan Potter. He was my buddy my freshman year of college. Go over to my girlfriend, now wife's apartment, and he would literally, like a cat, shove his hand in her goldfish tank, grab one of those little fat-headed guppy things, and just, and then he'd lay on the floor saying, "I can feel it." He was like a nationally ranked kickboxer. I'm pretty sure he just got hit in the head too many times. Like, the guy was different. He would like party boy dance down the hallway to techno music. He was just a different character. So anyway, the other one. Oh, range. That's what it was. Both of these are going to have a domain of all real numbers. Okay? So domain is everyone who's allowed into the party. In this case, because I have no variables on denominator, I have no even radicals, I have no logarithms, everyone's allowed to the party. The range, that's the outputs, that's the y's, that's who's allowed out of the party. And these ones do have a restricted range. Because what's the highest that the y's ever go? 23, right? So the way you may have written this in Algebra 2, you may have just said y is less than or equal to 23. I'm cool with that right now. You may have seen that in full set builder notation. All y's such that y is less than negative or less than 23, where y is an element of the reals. Okay. I showed my Algebra 2 kids that. They didn't like it. But that is set builder notation. We'll cover it in section 1. We'll use it a little bit and then never again. Or, more likely, you've probably seen interval notation, also covered in section 1, chapter 1, which says I go from negative infinity to 23. Parenthesis means you can't touch it. Bracket means you can. Okay? So I know my kids, we started using that quite a bit last semester. What about ones who came from Spear or Work? Have they been starting to do interval notation more?
Spear, we did that like every section.
Okay, good. Good. So what about this one? What would the range be? Greater than or equal to -1, or I could just say from -1 to infinity. Okay? And again, you'd put the parenthesis on infinity because you can't touch infinity. It's just an idea. Was it? Someone said -1 and I wrote it. Okay. Rabbit memory. Okay. Someone said it, I wrote it. That's your fault. No brownie point. No. Okay. So, those things. How do I graph a quadratic? How do I start to tell you things about the quadratic? I want to start with baby steps. B2A, 75, 3. I want to start with baby steps. Let's do 18 and 20 at the top. One of them has a stretch or compression, the other does not. There you go. I would like you to graph those two. Try to use the negative b over 2a business to find your vertex and then perfect square steps from there. You can always confirm it with the calculator, that's fine. But I want to see, make sure that you can do it. Make sure you can do it that way. Thank you. Remember, this ain't a library. During your daily quiz or a test, I want you quiet and doing your thing. But when we're just practicing stuff like this in class, I want you talking to your neighbors. I want you discussing. I want you arguing about math. Okay? Before you start throwing points on there, make sure that you both got the same vertex. Okay? Why did you get negative and I got positive? Okay, those kind of things. It should be a discussion. We're set up. We physically arrange the space so you are in groups, so you're facing each other, so you can talk. I would like you to talk. I never did attendance. Okay. Where was Jack? Jack was in the back somewhere. Okay. Ava was over there. Ha! I win. Kai's up front. I, I might just say Elder Jackson. Like, maybe not. That might hurt your feelings. Okay. Um, Mariah or Maria is out. Quentin's out. And it was a Maddie, right? Yeah, it was a Maddie. And a Maddie was in the middle. Ah, there we go. Okay. There was a Max in the back. There you go. Emma's here. Okay, we had the two Jadens. We had Jaden and OG. The other Jaden is in the back corner. Ha! I win. Okay. Okay, not looking, not looking, not looking. Okay. Anna was... Anna. Ha! Okay. We had other Caden was also in the back. Where's other Caden? Ah, okay. We had Isaiah was back, right? Oh, Isaiah, because I see your last name and I think Land Ho, because you're huge, dude. Like, you're. Please tell me you're in some physical activity. Okay. Okay. Beta test, Caden. We got you. You were in the first group. First group, beta test. Okay. We had two Callies. We had Aslam Callie and we had new Callie. We had Carter and Eli and Brooke and OG Jaden and Finn and Matt. Kylie was in the middle. And Callie.
Right. So
Ow. Oh yeah, you're right. You're right.
I like the collaboration. That's how it should be all semester long. Well, not that. Hey, it looks like most of us are either done or just finishing the first one. I'm going to put the first one up here. Keep going. Nine fourths, negative 9/4, plus 9/2, 18/4 is 9/4 plus 6 is 24/4, 9 33/4. Check my mental mojo. Yes, no. Okay. So back 3/2 up, 33/4, 8 1/4. So 1, 2, 3, 6, 7, 8. So we get the vertex, and then the perfect square steps thing is kind of an issue. Okay. So that spot, see how it's halfway through the box, a quarter of the way through the box. Perfect square steps from there means that all of your successive points are going to be in that same spot. You just move that many boxes. This has a stretcher compression of 1. So I get to use my normal perfect square steps. It's just they're all going to be negative. Sad problem. So I will go over 1 down 1 box. Over 2 down 4 boxes. Over 3 down 9 boxes. Over 4 down 16 boxes. Okay? Because you use perfect square steps. Horizontally 1, vertically 1 squared. Horizontally 2, vertically 2 squared. Horizontally 3, vertically 3 squared. Okay, so you get this idea of moving from this line. This is going to go down 1, down 4, down 9, down 16, because those are perfect squares. Okay, 1, 4, 9, 16, perfect squares. So if I have those points, I mirror them across an axis of symmetry. Connect your dots. Try to keep it curvy. Man, that's gross, but it works. Make sure you tell me stuff about it too. I have an axis of symmetry at x equals negative 3/2. I have a y-intercept of 0, 6. This is a maximum of 33/4 at x is -3/2. My domain is all real numbers because it's a polynomial. My range, I can either say y is less than or equal to 33/4, or I can go to interval notation, say -infinity to 33/4.
Perfect square stuff now a little bit higher.
Is it?
Because that one's the low one. It should be like 2.
1, 2, 1, 2, 3, 4, 5. No. From here, I would go over 1, 2, 3 down. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Why are we going down 9 instead of keeping us the perfect square?
9 perfect squares. I move horizontally 3, I move vertically 3 squared. Okay. Where it gets really funky is when you have some fraction vertex like that, and a fraction stretch or compression, and you need to change the scale to fit your vertex. Then that's just trash. That's trash. That's tough.
So do we only change our scale if like whatever we get from like our coordinates is out of like the scale range, or do we change it if like the stretch is
Whenever you want to. See, that's the thing about graphs is you get to make the scale whatever you want to. Like the example that I always use was about a year and a half ago. South Dakota decided we would no longer give a flying fornication about the pandemic because there was this famous graph that came out that said, look, we flattened the curve. But the scale on it was logarithmic. 100, 1,000, 10,000, 100,000, million. And it was in really, really tiny print. You can make the scale whatever you want to make it look the way you want it to. If it is convenient to you to change the scale so you can fit a vertex, because you don't want to go off-road or it's way too tall, change the scale. If you want to change the scale to match a stretch or compression, change the scale. You get to do what you want. I have some kids who just hate this beyond all belief, and they'll just take an entire page to do one graph, just so they can keep it as a scale 1. Right?
So it doesn't. So when you graph it, so it doesn't matter what your stretch or compression is if you go by like you just do it by splitting.
I mean, you have to understand that your stretch or compression changes how far you're moving with your vertical spacing. But the cheat mode is if I make my scale match my stretch or compression, then I can just do 1, 4, 9, 16 every time.
So for like the next one, if I went by like just the regular thing, I have to multiply everything by 4.
Yes.
So like 4 times 1.
Yup. So that means that it would be this skinny, mini little parabola. But if I make my scale go by 4, then it'll look normal. Yep.
No.
Okay. I'm putting the next one up because it looks like most of us are there or finishing. So, negative b over 2a is a positive 12/8 or 3/2 again. Is 9/4 cancel? 9, 9 minus 12, negative 36 halves. It's 18, 9 minus 18 plus 9, 0? Oh, it's a perfect, okay. Y'all recognize perfect square trinomial? Okay. That means its vertex is at 0. It's at the x-intercept. So, Narf, I teach math. Okay, so I got my vertex. 3/2, 0. Shoop. It's a happy parabola. So here's what, crap. Anna?
Yeah.
I win. Here's what Anna was talking about, saying that stretcher compression thing. If I don't change the scale right now, I'm not going to fit very many points on here. Because see how that a value is 4? I have to take all of my perfect squares and multiply them by 4. It is 4 times taller than it should be. So from here, if I went over 1, up 1, I would need to multiply that by 4. From here, if I go over 2, up 4, I would need to multiply that by 4. 16. You see how you're already so far off-road. And you would get this like really skinny parabola. I don't want a skinny parabola. Maybe I'm going to change those, and I'm going to tell this to go by 4 so that I can just use my regular scale or my regular perfect square steps. So when I say over 1, up 1, box, how far did I really go up? Okay. If I say over 2, up 4 boxes, I just went up 4 times 4. I went over 4 up 16 because I changed my scale. And now I get to use my normal perfect square steps. 1, 1, 2, 4, 3, 9, 4, 16. I don't want to do it. And connect the dots, but actually hit the dots. Okay? If I change the scale to match my stretcher compression, then I can just make the same graph every time. It would just be the vertex that's changing. That skill is going to come in super handy when we get to chapter 4 and we're doing periodic functions. We're just going to make the scale fit what we want to do. So you make the same graph every time. Because otherwise it's, instead of doing this every time, one of yours is going to look like this, and then the other one's going to look like this. I would rather just make this every time and relabel it. Okay. So, oh, and then our domain is all real numbers. Our range is everything 0 and greater. Minimum of 0 at 3/2, on and on and on. So, dare I ask, can we handle a fraction? We're not going to get to solving today. We just have to do all this work remembering how to graph quadratics. Get them. They're like, oh no, there's a fraction. We're gonna die. Or it turns out it's actually not that bad when you find your vertex. It's big, it's not fractiony. That's 5, -4, -4, 16, 16, 4, 3 halves, 4, -12, 12, it's 24, 30. Right?
How would we do this? Yeah.
I want you to problem solve.
Oh, so if you multiply the square root by
12, 24 is 12, 12, 6 is 18. Sounds like most of us are on our perfect square steps now. Did we have 418 for a vertex? Okay. And the question is just how the crap do I fit that on here? Okay, so we all know vertex is 418. I hope we know. Negative b over 2a. Plug it in. Let the calculator do the work for you if you can't fraction. We know it goes downward. We know we have to change the scale to see the vertex. Sometimes you just gotta think. Now, if this scale is going by 2, you know you can always do one of these to remind yourself. So you remember half a box is 1. Hi?
So if on the other ones, like the 4, we just set the scale to 4, why couldn't we just set the scale to 2 and 4?
I could set my scale to 3/4, but how many boxes at 3/4 apiece would you need to get up to 18? Okay, we simply just don't have that amount of room. Now, this is where if you're doing your own graph instead of trying to fit it to a graph, I just wouldn't have the negative part of this at all. I would almost start it like an L graph. So I could go up that high and use 3/4. That's what I would do on my own paper with just graph paper. But here, I just got to think. If I'm going over 1, how far down are we going? Not boxes, but how many units are we going down? 3/4, right? Over 1, down 1, times my compression. So over 1, down 1, times 3/4 is over 1, down 3/4. So I will go 3/4 of the way to this line. Over 2, normally down 4. How far am I going now? Norm.
1.5.
That will be a problem. Over 2 down 4 is normally. Over 2 down 3/4 of 4 is over 2 down 3. So over 2 down 3. Over 3 down 9 times 3/4. So over 3 down 27/4, or 6.5 ish, right? That many boxes. So down, oh wait, but I'm going by 2s. Ew. So down 1, 2, 3, 4, 5, 6.75. You see how that fraction really starts messing with us. So what I would do to have less headache, choose perfect squares that are divisible by 4. If I go over 2, I'm supposed to go down 4. 4 times 3/4 is just 3. If I go over 4, I normally move 16. 16 times 3/4 is 12. I'm going to go over, I'm not going to have those middle ones. I'm not going to have this. I'm not going to have this. I'm going to go over 2 down 3, over 4 down 12. 2, 4, 6, 8, 10, 12. Over 6 down 36 times 3/4, 27. Yep. So over 6 down 27. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 27. Mirror them across. Mirror them across. Over 8 down 64 times 3/4. Well, that's already off-road. Okay. Okay. If you remember how to find the vertex on your calculator, trace will not get you there. Second, right above trace, is calculate. Okay. So let me double check the homework to make sure that it is only graphing, not solving. When you come back tomorrow, we'll do solving quadratics and maybe move into section 4.